Again, real quick, students at home, we're reviewing for our quiz that we're taking tomorrow. And it is not a homework quiz, it is a regular old, like a mini test. 12 questions. Students at home, if you download the PDF of this worksheet, this is very similar to what the test is going to look like, or the quiz is going to look like tomorrow, okay? Question number 1 is the exact question right off your quiz, okay? This is the only tangent graph you're going to have to graph. The only one, because over the last week and a half or whatever we've been doing this, we haven't done any tangent graphs. I showed you a tangent graph and said that's all you got to know. We're not going to move the tangent graph at all. We're just going to, I want you to know what it looks like. So I want, and every one of these I want one cycle, just one cycle, okay? So our tangent graph, you remember, at pi over 2, there's an asymptote, and at negative pi over 2, there's a vertical asymptote. And it goes through 0, 0, and it goes like that. And that's the question, that's the answer, okay? So number 1, when you get your test, your quiz tomorrow, that's what it is. Asymptotes at pi over 2, negative pi over 2, and it goes like that. That's one cycle of it. If you remember when I showed you it the first time, I did like 3 or 4 cycles of it. You only need one. Every one of these, I need one. Okay, now, do you have to make little notes to yourself on these? I would when you need to. This one, I mean, there's really only one note you'd have to make to yourself. I mean, actually maybe 2 notes. What are the 2 things you could put down? I mean, you don't have to. But I'm telling you right now, when you get to like question number, 10, 11, 12, I can't do these without making notes to myself. I just can't do it, okay? So if you want to make a note to yourself, what's this negative 5 going to do? It's going to do 2 things to this sign graph. It's going to flip it, and it's going to go from what to what? Negative 5 to 5. So you could write negative 5 to 5, flip. If you don't write that down, am I going to mark you wrong? No. But that's one that, there's so little you're doing to the graph. Okay, and you have to put, you got to have these memorized, 2 pi, pi over 2, and 3 pi over 2. Okay, you've got to have, if you don't label any of your hash marks, you're going to get every question wrong, okay? And you've got to know where a sign graph starts. Where does a sign graph start, in the middle or the high or low? In the middle. So at 0, 0, at pi over 2, we're at negative 5, at pi, we're back up at 0, 3 pi over 2, we're up at 5, 2 pi, we're back down at 0. Any question on that one? Hopefully that's a pretty straightforward, easy one. They get progressively tougher though. Y equals 4 cosine theta. I mean, there's really only one thing. I'm not going to write a note on this one. This fluctuates from negative 4 to 4. I mean, if you want to write it down, go ahead. But, I mean, if I do this, did I write it down? Did I write down negative 4 to 4?
Yes.
Yeah, I basically did. I mean, so if you want to write it in words, you can. 2 pi, pi over 2, 3 pi over 2. And again, you've got to have this part memorized. Most of these I want you to understand. There's a few things you got to have memorized. You got to know where a cosine graph starts. Does it start right in the middle?
No.
No, it starts at the high or low. In this case, it's at high or low. High, because it's not flipped. So we're at 0, 4. At pi over 2, we're down at 0. At pi, we're down at negative 4. 3 pi over 2, we're back up at 0. 2 pi, we're back up there at 4. And not that I want to do it, but if you connect these dots, it looks like a V. I got to take a point. It's not a V, it's a curve. It's a sine or a cosine wave. And again, I have a lot of students that do this, and they literally have a hard time connecting them. How you do it is this. Draw like a hill, like that. A hill, not like a slope. It's going to be a hill like that. And then turn it around like that. So we're making a valley and then another hill. It's got to have curvature to it. If you connect them with the straight lines and it looks like a V, I got to take points off. It doesn't look like a V. Hopefully you're sitting here going, these aren't too bad. I mean, they really aren't so far, I don't think. Y equals 3 cosecant theta minus 1. Okay. I am going to do this. Cosecant, I'm going to write sine underneath it in parentheses. I'm going to do a sine graph first. And then I'm going to do my cosecant graph after that. So draw a sine graph. And I am going to make notes here for the first time. Vertically, goes from -3 to 3, but it doesn't go from -3 to 3. What do I do to each of those values? -1. So vertically, it goes from -4 to 2. So we have -4, +2, and the midpoint is -1. That number up there, -1. And again, we put 2 pi, pi, pi over 2, and 3 pi over 2. A sine graph starts right in the middle, so it's 0, -1. This is not flipped, so at pi over 2, we're at the high point, 2. At pi, we're back in the middle at -1. At 3 pi over 2, we're at the low point, which is -4. And at 2 pi, we're back to the middle, which is 2 pi, or -1. And if you do this and move on to the next question, you get a lot of credit, but you don't get full credit, okay? I didn't ask you for a sine graph, I asked you for a cosecant graph. So what's the next thing we do? Asymptotes. At where? At -1, at pi, and at 2 pi, and it goes away from the sine graph. And again, to be real clear on this, technically, all I want is the cosecant graph. So could you erase the sine graph? You could. I'd prefer you don't. It's just easier for me to see if you have the sine graph first. But really, the only thing we really want is those two parts. But please don't erase it. It's more work for you and it's harder for me. Y equals -6 secant.
Do you have to draw the sine graph to solve it?
I'm sorry?
Do you have to draw the sine graph to solve it? Because you could just draw it at 2 up and -4 down.
I'd like you to. I won't mark you wrong. Just this is easier for me. Okay. Again, for secant, I'm going to put, this time I'm going to put cosine. Okay, we're going to draw a cosine graph and then do our secant graphs from there. So vertically, it goes from -6 to 6, sort of. So you have to add 3 to both of them. So vertically, it goes from -3 to +9. I am going to make one more note to myself. You don't have to, but there's a negative out front there, so it's going to flip it. You don't have to write flip, but you got to make sure you remember to flip it. Okay. So let's put everything on here. We got to go as high as 9, down to -3, and halfway through is +3. 2 pi, pi over 2, 3 pi over 2. Again, we're going to start out by doing a cosine graph first. Again, you got to know where a cosine graph starts. It doesn't start in the middle. It starts at the high or the low point. In this case, since we flipped it, it's going to be at the low point, down at -3. At pi over 2, we're going to be at the midpoint, which is 3. At pi, we're going to be at the high point, which is 9. 3 pi over 2, we're back at the midpoint, +3. And at 2 pi, we're at the low point, which is -3. And a lot of times, again, students have a hard time graphing these cosine ones. We're starting out drawing like a sloping hill, okay, I don't know, part of a U, okay? Then we draw a hill, a whole hill, and then turn it around the other way to finish it out. Again, I don't want a cosine graph, I want a secant graph. So we're going to have 2 asymptotes at pi over 2 and 3 pi over 2. We draw it away, and then here it's going towards the x-axis, so we draw away from the x-axis. It's going towards the x-axis, go away from the x-axis. We went too fast, too slow, just right? Okay. Number 6. Y equals sine of theta over 6. Do we like it written as theta over 6 or not? Do we like that?
Yeah.
We like to have theta on top. We always want to have that, so we do want to have that, okay? What we do with this 6, in case we forgot, you multiply, well, multiply what by 6? 0 to 2 pi. This deals with, it's with theta. Theta is on the x-axis, okay? And you just the opposite. It's always the opposite. So horizontally, it normally goes from 0 to 2 pi. The first 5 questions all went from 0 to 2 pi. But we're going to multiply each of those by, it says divide 6, we do the opposite. We times 6, we times 6. 0 to 12 pi. Okay? That's the only thing it does. Instead of going 0 to 2 pi, it goes 0 to 12 pi. If you really want to, you can say vertically it goes from -1 to 1. I'm not going to do that though, because that's what they all do, unless you start moving them and stretching them. So we got 1 and -1. We have 12 pi. Cut 12 pi in half, you're at 6 pi. Cut 6 pi in half, you're at 3 pi. And then between 6 and 12, in case you forgot how to do this, to find the middle of any two numbers, add them up, divide by 2. 6 plus 12 is 18, divide by 2 is 9 pi. Sine wave starts right in the middle, so 0. At 3 pi, we're at the high point. 6 pi, we're at the low point. 9 pi, you're back at the midpoint. 12 pi, and then 12. Oh, yeah, and then, wait a minute. What did I do?
No, you should have it to the middle point.
Middle point, why did I say that? Thank you. We're back here at the middle. 9 pi, we should be down at the low point. Thank you. And back up to 12 pi. So say this graph ain't working. Ugh, that looks terrible. And where do we put our asymptotes? Nowhere. You only do that if you're doing the reciprocal trig functions. Okay, sort of halfway done. I say sort of because we've done 6, but we've done the 6 easier ones. Now we got the 6 tougher ones. Y equals -4 cosine 5 theta. Do we like it written as that? No. You don't want to have something times theta. You want it as theta over something. So that's the same as -4 cosine of timesing by 5 is the same as dividing by 1/5. Remember, you learned back in middle school, and it's not wrong, that dividing is the same as times by the reciprocal. Well, we want them to be divide problems. So multiplying is the same as dividing by the reciprocal. That's what we want. So vertically, goes from -4 to 4. I'm going to write it flips it also. Flips it upside down because of the negative. Then we do the same thing that we just did a second ago. Horizontally, it goes from 0 to 2 pi, but we're going to times each of those by 5. I'm sorry, 1/5. I don't know if I should show you this or not. I don't want to confuse people, but here's what we could have done. We're timesing by 5. You're always supposed to do the opposite, so what do? Divide by 5, which is the same as timesing by 1/5, same thing. So if you got that, great. If not, just keep doing what we've been doing. Okay, so horizontally it goes from 0 to 2 times 1/5 is 2/5. 2 times 1/5. And be careful, and even at this level, you guys, this is the highest level math class we teach here, I still see students doing this. So they go 2 times 1/5 is 2/10. No, you don't times the top and the bottom by 2, okay? I mean, think about it, forget about all this stuff. When you times by 2, you're doubling something, okay? Well, if you times the top by 2 and the bottom by 2, you're not doubling it, you're timesing by 1. You're not doing anything to it. 2/10 simplifies to 1/5. Times just the top by 2. 2 times 1 is 2. 1 times 5 is 5. Okay, so 0 to 2 pi over 5. All right. So we've got 4. We got -4. And we're going to go to 2 pi over 5. Okay. And then start cutting it in half. What's half of 2/5? 1/5. So 1 pi over 5. Okay, and then what's half of 1/5? 1/2 of 1/5 means 1/2 times 1/5, which is 1/10. Okay, or what we could do is this. We learned this way of just simply doing this. Add your tops and your bottoms. What's 0 plus pi? Well, is that going to work on this or not? Let's just leave it as. What we'd have to have here is 0 fifths. 0 fifths. 0 is 0 fifths. Add your tops and your bottoms. 0 plus 1 is 1 pi. 5 plus 5 is 10. Do the same thing on this one. 1 and 2 is 3. 5 and 5 is 10. Okay? Think of it this way. This is, again, I've said this many times, this is not how you add fractions, but to get this, to find the midpoint, you add the tops and the bottoms, okay? And we're going to add 0. If I give you 0 plus pi over 5, well, add the tops. Well, this doesn't have a bottom, okay? Could I have made it 0 over 1? I could have. But why did I use 0 over 5? Common denominator, okay? So 0 fifths. That's what I did. Okay. Then what? This is a cosine graph. Starts not in the middle. It starts at either the high or the low point. In this case, since I flipped it, it starts at the low point. At pi over 10, we're at the midpoint. At pi over 10, or pi over 5, we're at the high point. 3/10 pi, we're at the midpoint. 2/5 pi, we're at the low point. So have it cave in, then draw a big hill, and have it cave in again. Cosecant theta minus pi over 8. Okay, so, and again, I'm going to, underneath the word cosecant, I'm going to put sine. Okay, so vertically, this goes from -6 to 6. That's not going to change. Okay, horizontally, it normally goes from 0 to 2 pi. So it normally does. So we have this pi over 8. Are we going to multiply or divide by pi over 8? What? Everything's the opposite. It says theta minus pi over 8. We add pi over 8. We don't multiply or divide. Now everyone, why did we do it here? Because we were multiplying. Okay? Here we are subtracting, so we add pi over 8. Add pi over 8. 0 plus pi over 8 is pi over 8. I'm going to rewrite 2 pi a different way. 2 is the same as what fraction? You could say 2 over 1. You could.
16 over 8.
Why did you say 16 over 8?
Because there's 16 eighths and 2.
Right, you want to have a common denominator.
Yeah.
Okay? And again, just take your denominator times 2. 16 eighths. 16 over 8 is 2. So 16 eighths plus another eighth is 17 pi over 8. Okay. All right. Oh, I'm going to make one more little note here. This is flipped because of the -6. So we go from 6 to -6. And we have 17 pi over 8. If you're wondering, well, where do I put pi over 8? Somewhere to the right, just somewhere, okay? Just put pi over 8 right here. Okay. Without simplifying, what's the middle of 1/8 and 17/8? 18/16. I wrote that off to the side because I do want it simplified, okay? 18/16, 2 goes in 9 and 8 times. I hate doing this, but don't do what I just did. What's wrong with what I put? You got to put the pi on there. Okay. What's the middle of 1/8 and 9/8? 10/16, which is 5/8. 5 pi over 8. 9 and 17 is 26/16, which is 13/8. Just adding the tops and adding the bottoms and simplifying. What if you don't simplify them? You got to take a point off here or there, okay? I don't want to do it, but you got to Put the simplest answer. Okay, it's a sine graph, which starts right in the middle, not at 0, 0 though. Pi over 8, 0. If we shifted this thing over, pi over 8 units to the right. At 5 pi over 8, we're going to be at the low point because we flipped it. 9 pi over 8, we're back at 0. 13 eighths, we're at the high point of 6. 17 eighths, we're at the midpoint again. But I don't want a sine graph, I want a cosecant graph. Asymptote here, and here, and here. Number 9. Equals 5 secant theta plus pi over 7. Okay, underneath secant, I'm going to put cosine. Okay. Okay, vertically, goes from negative 5 to 5. Horizontally, goes from 0 to 2 pi. But it says theta plus pi over 7, so when you do the opposite, we need to subtract pi over 7. 0 minus pi over 7, and don't make this mistake, it's not pi over 7, you guys know that, it's negative pi over 7. In 2, well, last time we made 2 into 16 eighths. We could do that. You want 16 eighths? No, you guys want what? 14 sevenths. Common denominator. 14 sevenths minus 1 seventh is 13 sevenths. 13 pi over 7. Okay. Hopefully this is still recording. Yes, it is. Good. All right, so now be careful here. We're going to go from 5 to negative 5. Don't do this. Don't put negative pi over 7 here. I don't care where you put negative pi over 7, but it better be on the negative side. Okay? Better be to the left. And then positive 13 pi over 7. What's the middle of negative 1 seventh and positive 13 sevenths? 12 fourteenths, which is the same as 6 sevenths. Okay. What's the middle of negative 1 seventh and positive 6 sevenths? 5 fourteenths, and that doesn't simplify. Middle of 6 sevenths and 13 sevenths is 19 fourteenths. Okay, a cosine graph starts at either the high or the low point. It's not flipped, so it starts at the high point, and it's not 0, 5. It's negative pi over 7, 5. We're at 0 at 5 fourteenths. 6 sevenths, we're at the low point of negative 5. 19 fourteenths, we're back at 0. 13 sevenths, we're back up at 5. Number 10.
Wait, do I gotta put asymptotes on that one?
Why?
Because it's secant.
Very good. We're not done with this one yet. I want a secant graph. So an asymptote at 5 fourteenths pi and at 19 fourteenths pi. It goes away, goes away, goes away. When I say goes away from the x-axis. Now, you do that on your test. You're going to get points taken off? Yeah. You going to get a ton of points taken off? No. I mean, you will. I mean, each is worth 5 points. I'd probably take no more than 2 off. But, you know, points add up. I mean, you did the hard part. You just got to finish it out. Okay, now these last 3, this is where they start getting tougher. Okay? So, vertically, goes from negative 8 to 8. Okay. horizontally, what do we look at next? And we looked at the 8. What's the next thing? The 6. Okay? So it goes from 0 to 2 pi. I'm showing all my steps, but I really wouldn't have a problem. What are you going to do with each of those? Times by 6. Okay? You should be able to do that in your head. 0 times 6 is 0. 2 times 6 is 12. Okay? If you don't want to show your work on that, I'm cool with that. 0 to 12 pi. But it doesn't go from 0 to 12 pi. We're going to do one more thing to each of those. Add pi over 2. Okay, so 0 plus pi over 2 is pi over 2. And I'm going to rewrite 12 as 24 halves. 24 pi over 2 plus pi over 2 is 25 pi over 2. Now we're ready to graph this. 8, we have negative 8. 25 pi over 2 at the end. Pi over 2. Without simplifying it first, the middle of 1 half and 25 halves is 26 fourths. We added 1 and 25, we got 26, 2 and 2 is 4. 2 goes in here 13 and 2 times. 13 pi over 2. The middle of 1 half and 13 halves is 14 fourths, which is 7 halves. 7 pi over 2. The middle of 13 over 2 and 25 over 2 is 38 over 2, which is 19. I'm sorry, 38 over 4, which is 19 over 2. Now, hopefully you guys know this. When you look at these, 1 to 7 to 13 to 19 to 25, those are all 6 apart. Is that a coincidence? No, if the denominators are the same, the numerators better be evenly spaced. If they're not, you made a mistake. I mean, we're trying to cut this up evenly. Okay, a sine wave starts in the middle. Be careful, it doesn't start at 0, 0, though. It starts at pi over 2, 0. It's not flipped. It's a regular little sine graph, so up at 7 pi over 2, we're at 8. 13 halves, we're back at 0. 19 halves, we're at the low point of negative 8. 25 halves, we're back to 0. Two more to go. Oops. All right, these are the ones that have everything. All right, it's negative 5 cosine theta minus pi over 5 over 3 plus 2. Okay, so vertically, negative 5 to 5, add 2 to each. Negative 3 to 7. Okay. I am going to skip a step here. Horizontally, please speak up if you don't know where I got that from. How did I get 0 to 6 pi? What did I do? Times them by 3. And when you times 0 by 3, it's 0. Okay? So if this was a 10 right here, if that was a 10, I'd have wrote 0 to what? 20 pi. We good with that? I mean, if you want to show your work, go ahead, but you shouldn't really have to on that. Okay, one more thing to do. Add pi over 5 to each of these. 0 plus pi over 5 is pi over 5. 6 is the same as 30 fifths. 30 pi over 5. Okay? 30 pi over 5 plus pi over 5 is 31 pi over 5s. And go as high as 7, as low as negative 3. The midpoint is positive 2. We're going as far as 31 pi over 5, and we're starting at 1 pi over 5. Without simplifying, 1/5, between 1/5 and 31 fifths is 32 tenths, which is 16/5. This one doesn't simplify. Between 1/5 and 16/5 is 17/10. Between 16/5 and 31/5 is 47/10. Now, I pointed this out earlier, just on the last problem I did. 1 to 17 to 16 to 47, are those evenly spaced out like here they were? It's 1 to 7 to 13, they're not evenly spaced, why? Because the denominators are not the same. Had we kept our denominators the same, the top numbers would have been evenly spaced out. So why did we change the denominators? To simplify it, we had to, okay? 32/10 is 16/5, okay? We simplify it because we're not done. It's simplifiable. Okay, a cosine graph, and I could have made another couple of other notes here. Just gonna flip it. It's a negative cosine graph, so it starts at the low point. And don't get in a big hurry, students, it all starts down here at 0, -3. No, it doesn't. Not at 0, -3. Pi over 5, -3. We shifted it over pi over 5 units, okay? At 17/10, we're at the midpoint. At 16/5, we're at the high point. 47/10, we're back at the midpoint. 31/5, we're back at the low point. Have it go in, great big hill, have it sag in again. In all honesty, I mean, if you can do 11 and 12, you can do anything on this worksheet, really. I mean, you really can. Because that has everything on it. With that being said, I have no idea why, but I always have students say, like, man, I struggle with like questions 3 and 4. Just, then study them a little bit. I mean, they are easier. It's been so long since we did the easy ones that they forget how to do the easy ones. Y equals 4 cosecant theta plus pi over 2 over 5 minus 1. Last one. Okay, so I'm going to write, first off, it's a cosecant graph, so I'm going to put sine underneath it. Okay, so vertically it goes from -4 to 4. So we subtract 1 to each. Vertically it goes from -5 to 3. Then we look at 5. Horizontally, again, I'm going to skip a step here. It goes from 0 to 10 pi. Okay? It says divide 5, you do the opposite, you times 5. Everything with theta is the opposite. Then I have to subtract pi over 2 to each of them. 0 minus pi over 2 is negative pi over 2. 10 is the same as 20 halves, 20 over 2. 20, take away 1, is 19 pi over 2. Okay, so I'm going to get as high as 3, as low as -5, and the midpoint is -1. Okay, we're ending at 19 pi over 2. Negative pi over 2, I don't care where you put it, but it better be on the left side of the y-axis. Negative pi over 2. The middle of -1/2 and 19 halves, -1 and 19 is 18 pi over 2. I would do this. Here's what I would do. I would leave it for right now 18 pi over 2, okay? I should have said this at the beginning of these problems. I think it might be better if you lightly leave them before you simplify them, okay? Because, I mean, what does that simplify to? 9 pi. And we're going to put 9 pi there eventually. What's the benefit of leaving it like this right now? Common denominator, okay? Keep your common denominators until the very end, then switch them. The middle of -1/2.
Mr. Ko.
Yes.
Shouldn't it be 18?
Oh, yes, thank you.
He does it.
Yep. Sometimes I try to trick you guys or mess up, I just messed that one up. I was adding fractions the right way. We're supposed to add them the wrong way. To do it right, you gotta do them wrong. If that makes sense, okay? So 18 pi over 4, Oh, let's actually simplify that right now then. Okay, so that is 9 pi over 2. So just ignore the last 45 seconds of what I've been saying. Okay. And what's the middle of negative 1/2 and positive 9/2? That is positive 8. Now this one right here is positive 8 over 4, which is 2 pi. And the reason why I wrote that right now and simplified it is we're not going to chop that up anymore. Okay? Same thing here. 9 and 19 is 28 over 4, which is 7 pi. Could you put 7 pi over 1? You could. I mean, I'm not going to mark you wrong, but I mean, you don't need the 1 there. Okay, so a sine graph. It's a regular old sine graph. Didn't flip it, so we're at negative pi over 2. And be careful, a lot of students, oh, we're negative pi over 2, 0. No, we're not. Negative pi over 2, negative 1. That's a little lower, but I ran out of room. At 2 pi, we're at the high point. At 9 pi over 2, we're at the midpoint again. 7 pi, we're at the low point. 19/2, we're at the midpoint again. And it goes up, down, up. But I don't want a sine graph. I want a cosecant graph. So an asymptote, negative pi over 2, 9 pi over 2, 19 pi over 2. It goes away from sine graph. And one more thing, I haven't even said this to you guys yet. I taught in Algebra 2, I know I said this. Just be careful. These are really quick graphs. I didn't say quick. I just want rough graphs. I mean, we're plotting 5. If you remember when I first taught you guys this, we plotted like 25 points or something like that. Now we're just doing 5 points. I don't want to mark you wrong, and I probably wouldn't mark you wrong. But if you drew this, if you did this, I probably should take a point off, but I probably wouldn't. You know, you do a quick rough graph. What's wrong with that? It goes past the asymptote. Okay, how about this? What if you do this?
Now it looks like it's going.
It don't look like it's going away. It's going away. Okay, it is going away. So, I mean, it should be, you know, you don't have to make it perfect, but I probably wouldn't. But just, it's a bad habit. Just don't.
Like the second one, if you made it so it looks like it's moving back through, now it's going to hit the other asymptote.
This one? Right here? Or
Yeah, that second example you gave when it just overhooks.
Oh, then it would, yeah, then it, I should, I probably wouldn't. Okay, it's just a bad habit. Just don't do it, but I probably won't mark you wrong. Okay, study tonight, guys.